All right, for example one, I'd like to solve a rational equation. So now we're not just like adding or subtracting fractions together, but we actually want to find all numbers that make this equation true. So a good strategy is to cancel the denominators, and you can do that by multiplying both sides by the least common denominator. So I think off to the side here, I'm going to think about what the least common denominator is. So I see an x, a 2, and a 5. It actually turns out that the product of these three things will be my least common denominator. X, 2, and 5 share no common factors, so if I multiply both sides by 10x, every denominator should be canceled to just a 1. So let's see. On the left, I'll multiply by 10x, provided that I also do the same thing on the right. And you can actually just jump to this next step. You can write the 10x next to every single fraction that appears that's separated by a plus or a minus sign. So this is 10x over 1 that's being multiplied to 1 over x. Then we have 10x over 1, which is multiplied to a half. And this is equal to 10x over 1 times 4/5. So what this will do is just take us back to a more familiar equation. So if I do have the least common denominator, I can cancel this x with that x. This 2 goes in there, leaving me with 5. This 5 goes into this 10 twice. So all of the denominators are now just 1. And what is left over is 10. Here I have a 5x. And this is equal to 2 times x times 4, which is 8x. And here we go. This is actually just a linear equation. So we changed it from rational, having a variable in the denominator, to something we did way back at the beginning of the semester. So I'll subtract 5x from both sides. I'll now divide both sides by 3. And I'll leave this as my answer. 10/3 is equal to x. So this number makes the original equation true. One final thought on this equation is there's a 1 over x that appears in this problem. And that means x cannot be equal to 0 since you can't divide by 0. Had we gotten 0 as an answer, it would mean that we'd have to throw that number away. It wouldn't work as a solution. But that didn't happen. We got 10/3, and that is the solution to this equation. Okay, same idea in example 2 here. I want to find all numbers that make this equation true. It's a rational equation. I have variables in the denominator, and my goal is going to be to cancel all of the denominators. The least common denominator, if we examine it a little bit carefully here, this x squared minus 4 is x plus 2 times x minus 2. So this time, the least common denominator is actually just that, x plus 2 times x minus 2. The product of those two things appears in every single term. So I'm going to multiply that to both sides, but I'm going to jump ahead to just writing it next to each fraction. So that is, I have x plus 2 times x minus 2 over 1. That's multiplied to 2 over x plus 2. I'm going to add to that x plus 2 times x minus 2 over 1. And that's multiplied to 4 over x minus 2. And on the other side, I have, again, x plus 2 times x minus 2 all over 1. And that's times 11, x minus 11 over x squared minus 4. So now we can just try to cancel all of the factors between the numerators and the denominators, and it should work out nicely. In fact, in the first fraction, I have x plus 2, which cancels with this x plus 2. I have x minus 2, which cancels with that one. And since x squared minus 4 and x plus 2 times x minus 2 are the same thing, this completely cancels with both of those. And what remains is 2 times x minus 2 plus 4 times x plus 2, and that's equal to x minus 11. So to solve this for x, this is again now just a linear equation. I get 2x minus 4 plus 4x plus 8 is equal to x minus 11. So let's see, that's 6x plus 4 is equal to x minus 11. Subtracting x from both sides and subtracting 4 from both sides gives me 5x is equal to negative 15. Dividing both sides by 5 gives me x is equal to negative 3. And we could check to see that's a solution. But one thing to look out for would be all the numbers that could not be solutions to the original equation. And if you look at the denominators, you have x plus 2 and x minus 2. And this thing is just the product of those two. Negative 2 and positive 2 could never be answers to this equation because they would create division by 0. But the answer we got was negative 3, not a negative 2, not a positive 2. And therefore, x equals negative 3 is the solution to this equation.